Welcome to Talking Comfort Live, a show that reminds us just how cool HVAC can be by discussing today's hot topics in home comfort. From learning to laughing and sharing personal experiences to challenging the leading industry narratives, our show goes deep inside the world of mini splits, heat pumps, and the inverter technology that brings efficient comfort to our products. And you can help us in our quest to make HVAC cool. We're looking for you to be a part of the show. If you have a question, please send it our way. We might take it live. Grab a bucket and take a break. It's time for Talking Comfort Live.
Welcome back. I'm James McIntyre, Senior Director of Commercial Sales with GREE, and I want to thank you for joining us on this season's 6th episode of Talking Comfort Live. Today we'll be covering a range of topics that will help you provide your customers with the right comfort solution while delivering them top-notch support. Part of that comes from you simply asking questions or offering your opinion. This show is meant to be a gathering of minds, so please get involved and don't wait until the end. Send us your thoughts anytime. Use the question mark icon to the right of the screen. We'll keep rolling with any relevant questions that come until we run out of time. Today we have Justin Silsbury with us.
Hello.
We have Daniel Hamrick.
Hey, everyone.
And Greg Bruntz.
Good day.
All right, so for today, we're going to hear from Justin, who has a product update for you. Then we're going to talk about zoning and how it might not be a silver bullet for your home comfort. Then we'll welcome Vanessa back for her next entry in the Versus series as she talks about single speed versus variable speed heat pumps. Then we'll answer a comment or two left on the videos on our YouTube channel. And if we have time, we will have many other things to cover, including your questions. Again, this is your opportunity to connect with us and become more comfortable with the latest in GREE comfort. So let's start talking comfort. Justin, kick us off with your product update.
Okay, so today I'm going to give an update on the EPA's Technologies Transition Program. If you don't know, this is something we've talked about a lot on the show. This is regarding the program that's forcing the change from the high global warming potential refrigerants to the new low global warming potential refrigerants. In the case of GREE, going from R410A to R32. So last month, the EPA posted a rule proposal for VRF, or variable refrigerant flow systems. And essentially what that rule would do is it would allow for one additional year to transition VRF equipment from R410A to R32. So the new importation / manufacturing deadline would be January 1st, 2026. And this would also allow for R410A VRF systems imported or manufactured before January 1st, 2026 to be installed up to January 1st, 2027. It's very important to note that this only affects VRF systems that are 65,000 BTUs or above. Any systems that are 5 tons or below must follow the original transition timeline. Of course, that timeline being there's an importation / manufacturing deadline of January 1st, 2025, and you can install those systems up to January 1st, 2026. Now, the EPA is allowing comments on this new proposed rule up to July 26th. And after those comments close, they're going to do a final review, and then we would expect to see the final ruling published in late August. So as of right now, those are the only updates we have to the transitions program. Everything else for our FLEXX, ductless, mini splits, things like that currently remain the same. And all the other deadlines are still in place. That's all I have.
Well, thank you, Justin. All right, let's go around. Let's see here. Let's go around the horn and tackle some statements we hear being thrown around that we think is worth debating. To help with this, let's reintroduce our misnometer. What are we reading on our misnometer today? More zones always means better comfort. All right, who would like to go first on addressing that?
Well, I'll take it. So, more zones doesn't necessarily mean better comfort unless we're taking into consideration the load requirements of each room. And sometimes just because you can zone it doesn't mean you really should zone it. Sometimes it might be better to share zones and just have one thermostat controller controlling two rooms instead of, trying to segment it out, because you may not have enough load in a smaller room to accommodate size units that are available. So in other words, you might easily oversize the equipment, and then that's going to cause operation problems with the equipment. Too big is not good. And we've said that for years in the HVAC industry. Just because you can buy a bigger one doesn't mean you want to buy a bigger one, because if part of your cooling capacity comes from removing humidity, but they're controlled by temperature. So if the unit comes on and it cools the house down real quick, that's great, but it didn't run long enough to remove the humidity. So in a situation where you need 3 ton or 36,000 BTUs of cooling, you don't want a 5 ton that's 60,000 BTUs, because it's not going to run long enough to get humidity out. Whether you're in the north or the south, you still have to have a certain amount of runtime for the equipment. So we need to be more conscientious about, load requirements per room if you're separating up into different zones. Not that it can't, there's plenty of application we can do that. It's just not always the best answer.
Right, that's a good point, okay? That's a good point. Would anybody else like to add anything to that?
No, I think Greg hit the nail on the head right there. Everybody needs to do the room by room load calculation, see exactly what BTU requirement each room has. And I think most of the time people will see that, a lot of rooms in certain houses will have a load requirement that's smaller than, the indoor heads that we sometimes make, right? So it just makes more sense to combine those rooms together to get the load up to actually meet what the equipment is rated to do, right? You never want to oversize something.
Yeah,
Go ahead.
that, and to that point, I've seen it many, many times. And, tech support guys calling in, we've got a 9K because that was the smallest system or indoor unit that was available at the time. And now we've got a 10 by 10 room with a 9K in it in heat mode that could cause some issues. Then don't forget that now we actually have the options of the is it the 7K, Justin?
We have a 7K and a 5K.
Yeah, so now we have a little bit more option there for, if you do have a smaller room, we have the option for it. So,
well, and I guess, in the industry, we always talk about rules of thumb, right? So in a lot of applications, guys will go through, and I've seen it, I've done it myself. You go through a room just trying to get a rough idea. If you've got a completely forced air system, the rough rule of thumb was with 6-inch metal duct, you're getting roughly 100 CFM per run. So if you walked into a bedroom, the bedrooms and the living room and all that through the house, and it's all 6-inch runs, you go into a bedroom and it's got one run. So you figure you're putting roughly 100 CFM into that room. So and then the other rule of thumb's always been roughly 400 CFM per ton. So if you do that easy math and you walk into a room that's got one register in it existing, if you do the math, that's 100 CFM out of the 400 CFM per ton, which would be 12,000 BTUs, divided by 4, which gives you 3,000 BTUs. And now in that same room, kind of like you were just talking about, Daniel, now we put a 9K head in there. That's 9,000 BTUs of cooling in a room that used to get 3,000 BTUs.
Right. So you're saying 9,000 is a lot more than 3,000, right?
Last time I broke out a calculator, or my phone, teachers should always tease you. What are you going to do? Carry a calculator around with you? Yeah, as a matter of fact, I do.
yes.
Thank God.
Yeah, and somewhat related to this is the fact that, I've heard for years too that, I heard you can't oversize inverter driven systems. Then like maybe we should say you must not oversize inverter driven systems. It's like, it's not saying though, you can't do that, you know what I mean? There are still minimum run times. There's still, minimum run times for things like oil return. Like when somebody asks what's the minimum capacity that the system's going to output, it's kind of a red flag right out of the gate. It's like, what can I get away with, basically? Now, we do have equipment that's got, far larger return down ratio than other models, and we've got that information available, on our website. You can see what that looks like. But some others don't really have that, that low of a turn down ratio. I mean, it's still better than what a traditional system would be, right?
But I guess the other thing to look at too, kind of reiterate what you're saying there, James, is we don't size to the turn down ratio.
Right.
That's a bad idea. You're sizing the unit to run at its lowest possible capacity.
Right. Yeah. I actually recently had a friend that had it was a two-stage system that was put in, and it was 1 ton larger. It was a 3 ton that they took out. They put in a 4 ton, but this house had been completely remodeled. New insulation in it, new windows, new doors, new everything. And I mean, I know the thought process. The thought process was like, oh, I'll get you a 4 ton, and if you need more capacity, you'll be able to get it. But the problem is they had high humidity like constantly. That's all they ever had. I mean, we're talking 75, 80% constantly. And it never ran in second stage. Like it never really even had an opportunity to do so because, I don't remember exactly what the turn down was for that, two-stage system. I haven't dealt with two-stage systems in quite a long time. I don't think anybody on this team has. But let's say it's 3/4. Well, 3/4 of 4 tons is still more than what that house needed, And the first thing they said was, it's an old house. Well, the house, I guess technically, portions of the house were old, but everything else had more insulation than it ever had, I mean, we're talking they did Tyvek and all that all the way around the house, and so yeah, it was grossly oversized for it, and even with two-stage, it still couldn't handle it. And I wouldn't expect any piece of equipment to handle something that oversized.
I think it's important to note that even though we publish a range, a capacity range for the equipment, that is kind of for each different application, that's more of kind of a theoretical number in the fact that you can't force the unit to run at the lowest possible BTU setting. It's going to run based upon conditions. And what I mean by that is indoor and outdoor conditions and whatever the temperature sensors are feeding into the central processor of the unit, right? That's what's going to determine how it's going to run, not, oh, well, it says right here in the book that it can go down to 5K and that's what my room needs. So it's going to run at 5K, right? It doesn't happen that way. So do your load calculations, size the equipment appropriately.
Right.
Well, I think we all kind of, hit the nail on the head for all the same reasons. And let's be honest. Why are we talking about this? The reason we're talking about it is because we're having these calls. And we're having, what the end user thinks is an equipment problem when it's actually a sizing problem, which causes cycling problems, which causes overcooling or overheating. And I've got many examples of calls I've personally taken on it. And I don't throw names out there. I'm not trying to throw it in our bus, but it's things that we got to learn from that we pass on to other people to keep you from being in that same situation.
Right. Okay. Well, anything else to add from you guys? I mean, I think that was a lot of good information there. If not, then we'll move on to questions and comments. So it looks like we already have quite a few questions. If you are interested in leaving a question or a comment, hit the question mark icon and ask away. All right, so let's see. First one I'd like to look at. Okay, so we have this first question is, so it sounds like the terms inverter and variable speed are interchangeable. Are there differences in inverter technology from manufacturer to manufacturer? Who'd like to go first on that one?
Well, I'll jump in there.
I was looking at you.
Yes, we do use the term inverter and variable speed interchangeably quite a bit, but there is a bit of semantics in there you need to be aware of. So with variable speed, obviously that just means there is a wide operation range that a motor, whether it's your fan motor, compressor, etc., can operate in, and it can go in certain increments, in typically 1% increments as far as the speed, right? It just allows it to vary its speed upon demand based upon what the system's asking for. Inverter itself is basically taking your electricity, your power, and converting it from AC to DC voltage. And then there's a second part in that that's kind of, in addition to the inverter, there's kind of a variable frequency circuit in these. And so it takes that DC power that it's cleaned up, and then it uses pulse width modulation to pulse basically a three-phase AC power signal to your compressor. And depending on how much power or how long that signal is on, depends on how fast that compressor is going to spin. So I know we kind of use those interchangeably, because if you have a variable speed compressor, you're going to have an inverter, right? It's a necessary piece of equipment to have those. So even though we do use them interchangeably, there are differences. So it's really just kind of get into the engineering of it, if you want to break apart the circuit boards and everything. And then as far as manufacturer to manufacturer, there's going to be some differences in like your software of how they control it, when they do the speeds, how they're doing their temperature information as far as, when they want to do their turnaround ratios and stuff like that. But the basic components of the system, of your variable speed system with the inverter and all that stuff, you go to one manufacturer to another and you look at the boards, they're all going to have, your inverter circuit, you have the filter circuit, you have the pulse width modulation circuit. They're all pretty much the same. So if you've seen one, generally you've seen them all.
Right. Well, to that point, what I find interesting about that, since all the components are the same, a lot of the costs are going to be the same, regardless of the way it's programmed. And there are some very expensive systems out there that, that will tout that they are variable speed, and they may have 3 speeds, 4 speeds, 5 speeds, that kind of thing. And unfortunately, you pay for a whole inverter board and you're getting 5 speeds out of it, or 3 speeds, or, something like that. So you're paying top dollar for it, let's say. And you're getting 3, 4, 5 speeds, and it's like, oh, it's the latest in technology, that kind of thing. And it's not. Inverter's been around for 30, 40, 50 years at this point. But yeah, anyway, I know it seems like it's interchangeable. And in some cases we do definitely use that, but we do have a video from Vanessa that addresses just that topic. So we'll go ahead and move on to that and come back for a Q&A.
Welcome back to our Versus series. I'm Vanessa Steckler, and today we're diving into a hot topic: the difference between single-speed heat pump air conditioners and variable-speed heat pump air conditioners. If you're in the market for a new HVAC system, or just curious about how to easily explain the differences and how these two work, you're in the right place. First, let's talk about how these two types of heat pumps operate. A single speed runs at full speed or not at all. That means the compressor and fan operate at maximum capacity no matter the weather conditions. In contrast, a variable speed, also known as an inverter-driven unit, can adjust the compressor and fan motor speeds from 0% to over 100% and provide gradual speed increases even at startup. Now, let's talk energy consumption. Single-speed units require a high inrush current to start the compressor, leading to high initial energy consumption. You might even notice your lights dimming when the unit cycles on. Variable speed units don't have this issue. They adjust to match the load conditions, making them more energy efficient overall. So how about use over time? Single speed units tend to cycle on and off frequently throughout the day. This is very demanding on both the system and the grid, increasing the chances for electrical and mechanical issues over time. Variable speed units, however, run longer cycles at lower speeds to maintain the desired temperature. This means fewer start-stop cycles, reducing energy spikes and strain on your system. Temperature control is another crucial aspect. Single-speed units can lead to temperature fluctuations within your home, making it less efficient when trying to achieve a consistent indoor temperature. Variable speed units, on the other hand, continuously adjust the cooling demand, offering better humidity control and more consistent overall comfort. So what's the bottom line? Single-speed heat pump air conditioners are simpler and often less expensive up front, but they can lead to higher operational costs, more wear and tear, and inconsistent temperatures. Variable speed heat pump air conditioners offer superior energy efficiency, reduced wear and tear, and better temperature and humidity control, and can offer significant savings and increased comfort in the long run. So there you have it. Thanks for watching. If you found this video helpful, please give it a like and subscribe to our channel for more HVAC tips and insights. And if you're interested in learning more about our variable speed products, visit GREEcomfort.com. Stay comfortable out there. At GREE, we're by your side.
Hey, well, thank you very much, Vanessa. Would anyone else like to add anything about single speed versus inverter?
I think she got it.
Yeah, I think she took care of it, definitely. So we're going to head over to the YouTube channel at GREE Comfort and pick one comment to discuss. All right. This week, we're looking at our video, Hands-On, the GREE FLEXX installation and troubleshooting video. All right. So let's talk about the comment in the service manual. I'm not going to read all of that, but in the service manual, there is a what appears to be a typo. That's 01 denotes steer and forced operation, 01 denotes cooling mode, and then it says that 02 also denotes forced cooling mode. Can we confirm whether or not that is a typo? It's supposed to be cooling and heating, respectively, or if there's something else missing there? And Justin, would you like to?
Yes,
That portion? All right.
that was indeed a typo. 02 is heating mode. And I sent a message to my team just before we went live to get that addressed. So we'll fix that and get the latest, greatest manual posted upon there.
All right. And there's a second part to the question. Will this mode also turn on the air handler blower? And then they said thanks, which is very nice.
No, it will not.
All right. All right. So don't run it like that for an extended period of time, correct?
No, but even if you do, it'll protect itself. So
That is true.
you'll get an error code.
If you like me and you jump R to G on the or R to Y on the outdoor unit, it'll backfeed through the thermostat and turn the blower on for you. Because I'm not walking all the way in the house.
Ah, that's a good point. You're not walking all the way into the house. Well, you know.
That's a long walk.
The father of invention, right?
Well, that would be necessity, but apparently laziness also contributes to invention.
I know it's not required, but on the outdoor unit, there's a G terminal there. I know it's not used, but as you're installing it, if you go ahead and run your G all the way out to the outdoor unit, that just gives you an extra test point. And so when you're doing those tests, you can just jump R and G right at the outdoor unit.
Yep. It's a good point, Justin.
I like that.
Yeah.
And you're going to have too many wires anyway if you're on an 8-wire cable. So shouldn't be a big deal.
No, you just run 4 2-wire cables. Everybody loves that. Bunch of reds and whites.
Sure, why not?
All right. Let's take a look at another comment. You said earlier not to unplug components, specifically the outdoor fan motor when power is on. But now you're saying to unplug components to troubleshoot, as we might see the bus voltage go back up after being dragged down by a bad component. Which is it?
So, Daniel, I don't know if that was you that said that or me that said that, but regardless, what we meant was turn the power off.
Correct.
Then unplug it, then power it back
Then power it back up.
and recheck the DC voltage.
Right.
Right. And I know that we, talk about recommending the power being off for a specific amount of time, right? Or at least pretty much all manufacturers do. But since we know where we're going to be testing that DC bus bar voltage, is there a recommended voltage that we might wait until it gets to before we can unplug components?
Yes, I like to see it drop below 50 volts DC.
Right. So in fact, once the DC bus bar voltage drops below 50 volts DC, you should be able to disconnect the components as you see fit.
The reason for that is to minimize arcing when you're plugging and unplugging things that's got live potential to it.
Yeah.
Because arcing can actually damage components.
Right. And as a secondary note for Greg, it would also be for your safety.
Yeah. For their safety.
Right. It might be secondary, but yeah, we do care about you.
It's secondary for me. I like living on the edge, right? Thanks for reminding me to keep people safe, James.
Yeah, no problem, man. All right, so we also saw a UVW light tester on one of the slides. Can you tell me where to purchase one, as well as the EV magnets to manually rotate the rotor I guess on the EV? Thanks. I believe we commented back that they can check with their local suppliers to get those components, or, yeah, that would be the best place to check, correct? Everybody, okay.
That's what I would recommend, because we don't actually sell those components. We were using them in training and stuff like that, but we don't sell tools or anything like that. So they really just need to reach out to their distributor. And then, great resources online, tool sales and stuff too. So if they can't find it with their own distributor.
Right, okay. All right, so I'm going to get back to some of the Q&A here. Let's see. There's so many questions, so give me a moment. All right, where can we find updates in between our monthly shows?
So the best place to find updates on GREE products in between shows is simply to go to our website, greecomfort.com. As new things become available, we will upload those to the website. I know right now everybody's interested in seeing all the new information on the R32 equipment. And as that becomes available, we are posting that on the website. So I think right now we have the Levo, Invo, and Sapphire posted and available. We should have the Vario and Multi-Zone, new FLEXX Ultra and all that up pretty quick. And then if you're wanting to get updates on the latest and greatest EPA regulations, I know we're all trying to keep up with that. Just simply go to epa.gov.
All right, thank you, Justin.
And just for those that are not aware, when you're looking for documentation, make sure you're going to system documentation on our website. And I have to agree with Justin. I have seen, R32 documents popping up under different equipment. Basically on a daily basis, I've been seeing it quite a bit. So they, like you said, it is out there and they are being uploaded.
All right, thank you. Let's see. Looks like you're going to be a popular guy today, Mr. Stillsbury. Says that we can wait until the end, but why not cover it now? I'm wondering when the MultiPRO line will have an option for a coil only as part of the multi option. So we can pair with a furnace for a house and run an additional unit for a possible problem area in a house.
It's a great question. And that product is currently in development. Mr. Greg actually did all the testing on it. And according to him, there's just a couple things we need to change, but first test, everything ran great. And we're planning on having that rolled out, hopefully by the end of the year.
Yeah, so to comment on what Justin just said, I did test it and the controls work perfect. There's one little minor thing with the control that I know is not going to be a big deal to get fixed. Daniel was down there with me. We even repositioned the drain pan and everything for horizontal. If you got a horizontal right application that comes multi-poise, it can be horizontal left, horizontal right, or upflow. So, yeah, I'm excited. I can't wait for it to get launched. So it's coming soon.
That's great. I'm excited for it too.
Well, I guess one more thing to mention with that too is so you'll be able to tie that to any gas furnace. So, because it has the 24-volt adapter control board and everything on the coil. So you'll be able to tie in the outdoor unit, the MultiPRO outdoor unit, to the coil, and you'll be able to use whatever thermostat you want, whatever gas furnace you want, and try to tie in the 24-volt voltage. It should be pretty seamless with very minimal settings you would have to do or anything like that to make it all function.
Right. Well, I know that we covered some of the features of that, through our testing. I mean, these were all requirements that we laid out to them, and we've been very happy with, that they actually went far above and beyond what we originally expected as far as some of those features. But would you care to speak on, if you did have a problem with the unit or something like that? I mean, not only would you have backup gas heat, but you may also still be able to run the other indoor units as well. Is that right?
That's one of the things that we're seeing with So if you got a MultiPRO unit, even if you lose power altogether to the outdoor unit, which would effectively make it inoperational, you will still have functionability to the indoor units for if they have another source of heat. In other words, if you have an electric air handler with electric heat in it and the outdoor unit is down, you will still be able to run your electric heat in emergency heat mode. Same with gas heat. If the outdoor unit's down, you'll still be able to flip it to emergency heat and run the gas heat.
But what if we had, like, let's say a reduced capacity situation? Let's say it's very, very cold, not for the ultra heat equipment, of course, because it's still going to be able to operate heat pump. But if it was very, very cold, like the standard equipment wasn't able to necessarily keep up with the entire load.
So, for example, if like you were talking about what James was talking about, say you had 3 wall mounts and a gas furnace and coil, and that was your 4 indoor units, you would be able to run the gas furnace in emergency heat mode, effectively not using the heat pump at all. And let's say the system's low on charge and we don't have enough refrigerant in the system for all 4 units to work in heat pump heating mode. But we can maybe run that gas furnace in emergency heat mode, run the gas furnace, and then the 3 other wall mounts run off the heat pump, and then hopefully you would have enough refrigerant in there so that those units can still function.
Right. So that's that's like a dual backup system or something like that. It's not only gas furnace, but you also continue to be able to run heat pump, in those other zones, which will, it's very exciting to me because it opens up a lot of applications in areas where I guess traditionally the heat pumps wouldn't be used at all, but don't forget, we also have ultra heating equipment rated to -22 and 100% heating. So that's something we can't forget. Next we have, let's see, John from Chambersburg Supertex. As dealers, can we get access to performance data like temperature/BTU? I guess that would be capacity at certain temperatures so that we can size close to the heating requirement but also take into consideration the cooling need. Where would we be able to find that information? Well, I can tell you right now, you can find that on GREEcomfort.com under the specific product. And we have heating and cooling capacity charts available for our equipment. And you can take a look at a specific design temperature, outdoor design temperature, and see what that unit, whatever that unit's going to be, you can see what that unit would be capable of producing at that temperature. So,
yep,
it's going to be
available to you.
It's going to be called extended ratings, correct?
Yes.
So underneath this, underneath or near the submittals or spec sheets, there will be a link for the extended rating sheet.
Perfect. So when you do your load calculation, you try to figure out what your load's going to be, and then you look at your design temperature, you look at the extended ratings, or the design temperature on your extended ratings, and find out if that's the right heat pump for the job, right? Okay.
Correct.
All right, got another question. Let's see, when will the 7 and 5K be available in the CNY market? I'm going to assume that might be Central New York. When will that be available?
So the 5 and 7K heads have been available for over a year now. We currently have the 7K in stock. If you would like to get the 5K, those are container direct. So, if you want to work something out with your salesperson, you talk to them about that. I just want to point out that these are indoor heads only for the Levo series. There's no matching outdoor in a 1-to-1 configuration for 5 or 7K. These are specifically for the multi-zone models. Okay, so it's not 1-to-1, it's multi-zone.
Right, which makes sense because our smallest outdoor unit in a single zone is 9,000 BTUs, right?
Correct.
Okay. And we also have 5, 6, and 7 available through the MultiPRO line. So we should be able to meet just about any application you come across. Right? We got some more questions. All right, so does part load efficiencies come into play as they relate to energy? Part load efficiencies. As far as energy ratings, like how inverter-driven systems or variable speed systems are rated via SEER 2. In effect, if I'm not mistaken, Justin, you can correct me if I'm wrong, but in effect, the way they do the variable speed systems is they do rate, they will run that system at a particular speed, at different temperatures, and then effectively using part load and the efficiency at that part load as a weight, right? It's like a weighted amount.
Yeah, so typically what they do with the variable speed is they just lock in, the compressor and fans at a certain speed for certain temperatures, and then they run it. And basically it gives you a baseline comparison to, like any other piece of equipment out there, whether it's single stage, two stage, etc. It's basically just saying at at this temperature, at this hertz, so on and so forth, the unit draws this much power. Where you're going to really see like part load efficiencies is like in the new commercial products where they do IEER. That's when they're going to go in and rate it at, certain percentages at certain temperatures over the, course of a theoretical year and so on and so forth. When they're doing those efficiencies. Now, if you want to look at different kinds of information like COP and stuff like that, you can pull up our extended ratings, which has that information. So if you're wanting to kind of see efficiencies at different temperatures in your area, that's something you kind of take into account and look at. But rating the equipment itself, in the current form with residential equipment, I don't believe they're really taking into account the part load. It's pretty much all or nothing. It's the commercial side where you're doing the IEER where they're really taking into account the part load efficiencies.
Right, and I know we've discussed this before. I mean, just between you and I, and also on this podcast, but the way we are rating systems, using seasonal energy efficiency ratios are, trying to provide like an apples to apples comparison, across the board, single zones or single speed systems versus dual speed systems versus, fully variable speed systems. And, unfortunately, where variable speed systems really, really shine on energy efficiency are the part loads that are, 99% of the time or 75% of the time or whatever it may be. That's where they really shine. Unfortunately, that's just not really something that's easily measured. So therefore it's just not really measured that way, right? So if I took in effect, and you guys could weigh in on this, but if I took two 18 SEER pieces of equipment, one of them, in identical homes in the same spot next to each other, if I took an 18 SEER system that was fully variable speed versus an 18 SEER system that was a single speed 18 SEER system, if they're still available, I don't know if they are or not, you could pretty well guarantee that the 18 SEER variable speed is actually going to save you more money, and as far as in terms of energy usage than you could over a single speed or two speed, traditional system at 18 SEER, right? I know there's other variables and stuff like that.
Typically that kind of scenario that you're outlining there, where you have, a high SEER single or even a two-stage piece of equipment versus an equivalent SEER variable speed piece of equipment. That single or two-stage piece of equipment is really kind of brute forcing the number. You're going to see a much larger piece of equipment. You're going to see much larger coil sizes for surface area and things like that. Whereas the variable speed piece of equipment, you're going to have kind of smaller coil sizes, so you don't need the surface area for heat transfer and everything else. You're going to have no lock rotor amps when the variable speed piece of equipment starts up versus the single or two-stage piece of equipment. That right there is going to be a major savings in amp draw every time the unit starts up, right? As we all know, again, when they rate these pieces of equipment, they're locking it in and running it at, like your 95 degrees, right? And they're running it for so long and they're taking energy measurements and all that stuff, and they're rating the equipment. We all know that it's not going to be at that temperature all year round, right? You're always going to have cooler days for probably 80, 90% of the year when this thing's running and cooling, so to speak. And that single piece stage or two-stage piece of equipment is not going to ramp down to meet that lower load, whereas the variable speed piece of equipment will. So it's not rated that way. You can't really tell it, but you know when that system's able to ramp down to 20% instead of 80%, like a two-stage or something like that, there's going to be some energy savings there.
Right, yeah, I mean, in fact, I mean, instead of just turning it on or off within a certain period of time, because I mean, no matter how fancy a thermostat is, that's effectively what we're doing with the standard system, right? As soon as it's 94 degrees outside, I'm able to run a little bit less. I can actually slow down, continue to dehumidify, that kind of thing, and provide better comfort and also energy efficiency. I mean, I am using less energy at that point, right?
Yes, and effectively, if you look at another light, so even at 95 degrees, once we satisfy that load demand, let's say we got it set at 70, let's say we get it to 70 degrees, instead of cycling that unit off, we're going to slow that machine down and maintain that temperature at a much lower amp draw and keep the space at that 70 degrees, rather than shutting the unit off, waiting for the temperature to rise up to kick it back on again, hold that locked rotor ramps, and fire that compressor back up again. I mean, it's simple physics that inverter-driven unit's going to be more efficient, but able to just slow down and stay on and maintain the temperature rather than cycle it off and let the temperature go up.
Right. Well, and it's also, we see that every year. Summer coming up, they'll tell you, energy, providers will tell you things like, set your unit back to 78 degrees to save money, and stuff like, or 80 degrees was one of the latest ones I saw. I'm not going to go over to your house if it's set for 80 degrees, but that's effectively what they talk about, because the only thing, I mean, we have to get past the point of the only way to save energy is to turn stuff off. I mean, but that's what we have to do if we're using a traditional system, is turn it off. It's like being able to dim the lights in your house versus just turning them off. Maybe you still want to see, but maybe just not that well, maybe you got some mood lighting going on. I mean, in effect, you are using less power at that point, and it's going to save some money. And I think my wife would be happy if I turned down the lights a little bit.
Well, that's the one gain that the industry's got is going to all these LED lights, right? So now all that unitary product out there that's using PSC compressors don't make the whole lights flicker when every time the thing comes on, because the LED lights don't respond to that.
Yeah, good point. Good point. All right, we've got a couple questions about FLEXX systems, so I'm going to go ahead and combine those. Well, actually, we got three of them. All right. Can the FLEXX be put on a zone system? Anybody like to take a whack at that one?
Well, yeah, it depends on how much you're zoning it, and then whether or not you're using a bypass or a dump zone. You got to remember, if you're taking that thing down like only one zone calling, and you're taking that thing down below 50% or even 50%, and that thing's running heat pump heating mode, and now you got single thermostat demand, turn that machine on, that thing's liable to rev up pretty good, and we're going to end up out on an H4 on overload because of that machine not being able to dissipate its heat enough because we can't move enough air. Remember, on any zone system that if it's required, to move a certain amount of air, and the compressor can't effectively communicate like MultiPRO does, so the whole system works together and we slow the compressor down. We're doing with FLEXX, which is 24-volt controls. Yes, it can monitor the head pressure. Yes, it can control the RPM of the compressor to a point, but if you restrict that airflow too much, it can only save itself so much, because it just does not have the capability of like a MultiPRO system that has more than one input device into it to make sure we're not overheating the indoor coil. Is what I'm getting at. So, but then the same thing in cooling mode, if we're restricting our airflow too much, yes, it's got a pressure transducer. Yes, it sees that evaporator temperature. And yes, it's going to try to slow the compressor down and save itself. But again, if we get that airflow too low, can't move enough air across that coil, that evaporator runs too cold, it is going to freeze up.
Gotcha. So, I mean, in that case, you really want to know what the limitations of the equipment are, making sure that the zone damper system is set up properly. which,
Yep.
I mean, I know you in tech support know that they're not often set up properly. Do you need to make sure static pressure and stuff like that set up?
Absolutely. You
Okay,
got to
so
maintain proper static pressure, total static pressure drop across that indoor unit.
right, so it doesn't just come preset and ready to go. You know, it needs to be dialed in, right? Okay.
Well, and the way I always answered that, even when I supported unitary product, is look, there is no way for the manufacturer of that piece of equipment to know what ductwork you're applying that system to.
Right.
And what restraints you're putting to that system. So all they can do is put an average speed or what a recommended speed or suggested speed all on that unit, but it's up to that installer to make sure with the ductwork that they attached it to, the air cleaner that they attached it to, whatever other accessories they attached it to verify whether or not that thing is able to move the air through that system properly and without overly affecting the total static pressure drop across that unit.
Well, actually, and if I'm not mistaken, I believe that the default static pressure in CFM rated CFM is set for, M1 blower testing for HRI certification, right? I mean, that's why comes from the factory set like it is, right?
That would be a Justin question. I don't know exactly where they get their suggested speed setting. Do you know, Justin?
Sorry, what was the question?
Oh, that was the default static pressure and CFM rating of an indoor unit. Is that based on basically M1 blower testing, HRI, that kind of thing, where you pull? Yeah, okay. So you pull
Yes.
something off the shelf and it's already ready to go for that testing, right?
Yes.
Okay.
But again, the manufacturer doesn't know what ductwork you're installing that to, so it's up to that installer to make sure that speed setting and that static pressure is proper for the system to operate properly.
Yeah, basically, if you look in the submittals, we show the blower fan chart, and we give you a range that fan can operate in, and it's up to the installer to set it properly to get the right airflow for those conditions and make sure you have the proper ductwork. That's all we can say.
Yeah, or make modifications to the ductwork or whatever filters they're using, air cleaners. We know all these goods are out there. You got electronic air cleaners, you got media filters, you've got all sorts of different types of outlet registers. You have all sorts of types of inlet, return air grills. All of that plays a role in that total static pressure drop across that system. So there's no way for a manufacturer of a piece of equipment to know what you're actually installing that thing against.
Right. There's very little variance in the manufacturing of the equipment, but an infinite amount of variables in the installation of the equipment.
Exactly.
So speaking of the FLEXX, on the FLEXX systems, why, if I use another manufacturer's equipment, does it need a TXV? I thought there was an EEV in the outdoor unit. So that's actually a two-part.
I like that question. That's
a good question.
But
so why does it need a TXV?
But effectively, it's got two EEVs in the outdoor unit, but neither one of them are for cooling mode.
So neither one of them.
One of them is used in cooling mode to subcool the refrigerant a little bit, but effectively your metering device is still at the indoor coil on a FLEXX system, and they use the TXV for that. There is the other EEV in there is your heating metering device.
Right. So why do I need to have a TXV if I was using it with a third-party piece of equipment? Why do I need to have a TXV versus a piston type or a cap tube or whatever?
So because of the fact that a TXV, if I had to rate them, EEV is most precise, TXV is right behind it, the piston is least precise, and even one more step further, if you had a cap tube, that's even least precise because it's not actually monitoring the superheat and saturating that coil as well. So the one that works the best is the EEV. The TXV is right behind it. And as ease of installation and ease of you being able to install it to any other manufacturer's equipment, those coils already, most of them will come with 410A TXVs already installed on them. That's why you would just keep the TXV.
A large part of the TXV point to that is a TXV is generally on a high efficiency coil, and we need the coil space for the system. So your piston is a lot of times a lot smaller coil. So that's kind of the rule of thumb. Has a lot to do with it. It's just the size of the coil.
That and a piston doesn't maintain constant superheat. A TXV does.
Gotcha. No, that's a great point. Another FLEXX question. It's a popular product category today. It's a long way to say it, but when will a variable speed blower be available for the FLEXX system?
That's a Justin question.
Yeah, like when can I have a Y1, Y2, cooling call? I can get slower fan speed, better dehumidification, that kind of thing.
That's a great question. That's currently in development. We should be getting samples of our new FLEXX smart controller, hopefully within the next month or so. And that's going to be used in conjunction with our newest R32 FLEXX Ultra models. Those FLEXX Ultra models have an RS485 port on them. And that FLEXX Smart Control will interface with that RS485 port and should give us some variable speed control. So nothing set in stone yet. We're still developing it and testing it, but hopefully next year we'll be rolling out our new control that gives us full variable speed control on the FLEXX.
Gotcha. So Justin, is there anything that we currently carry that's already set up that way?
That's a great question, James. We have this wonderful, great product called the MultiPRO. It's fully communicating, fully variable speed, and it is our top tier product, but not top tier pricing.
Perfect. It's perfect. So if you wanted a fully variable speed air handler with a fully variable speed outdoor unit, with great turn down ratio, great dehumidification, also options to go -22 and 100% heating, that would be our MultiPRO system.
And also with the MultiPRO system, with the new 24-volt adapter is going to be coming out, you can use anybody's thermostat and effectively have dry mode, which is essentially dehumidification mode.
Good point. All right, finally for FLEXX. Look, there is a question mark icon. Be sure to hit that question mark icon and enter any comments or questions that you got. We're kind of winding down here. So get those in before the episode ends, otherwise you have to wait a month. All right. I have an old R22 condenser and coil and a newer LP furnace. What would it take for me to go to a FLEXX system? Well,
I'll let you have that one, Daniel.
okay, we'll let Daniel have that one then. Okay.
So pretty simple. An outdoor FLEXX and a case coil, right? And there you go. So the only consideration, and it's actually in the quick start guide for that LP furnace, is that you do a transition between the furnace and the FLEXX case coil. So there does need to be a proper transition there, so you got proper airflow. But yeah, that's the option.
Okay. What about line set? I mean, I hate to make an assumption here, but I think we might go in from R22 to R410A or even R32 if we wait a little while.
Replace it.
Replace the line set.
Replace the line set.
Yeah, there's nothing, there's no flush kit that's going to make it like a brand new one, right?
That's right.
Okay.
And I actually, in my own personal, I don't care for the flush kits because I'm afraid that, some of the chemicals they're using to flush it may be residual left in that line set and could actually do more harm to the system than if they didn't flush it at all. That's why I agree with Daniel 100%. The best way to, make sure you're selling your customer a new product that has no contaminants in it is to put in a new line set.
Right. Well, and if you're talking about a system that you're offering to a homeowner that you're replacing, right? You guys that are listening are absolutely the best techs out there. People that aren't listening, absolutely, they're probably not, right? do you want whatever they did to that system over the past 20 years to affect the system that you're selling right now? Like, do you want to affect it? Like, if I went and bought a new car and I found out they put used motor oil in it, I might be kind of mad about that, right? In effect, that's what you would be doing if you are, I mean, if you've got the option, if you can do it, if the customer is willing to pay for a new line set, I mean, that's the way I would go. So I can get a nice, brand new, squeaky clean system, you know? I mean, I've seen job sites where the line set wasn't changed out, but everything, including the ductwork, was. I just can't imagine why that would be why that would be done. And for the folks who do new construction, I know they want the line set inside the wall, I guess. But they're not thinking about you 10, 15 years from now. Just think about that, right? But
Hopefully
right.
it's drywall. Drywall is cheap.
Drywall's cheap. Finishing drywall's not. Unless you do it yourself, and that is definitely an art form. That's something I'm not good at all. That's why I do what I do instead of drywall. All right, let's see here. We do have a MultiPRO question. Let's say we have 2 air handlers with 1 outdoor unit, and we're using 1 controller. All right. Are we using the return air sensor in both of the units? Are we using the temperature that's being sensed at the controller? What are we doing in that case?
Well, if you're using 1 controller to control 2 indoor units on a GREE controller, it's going to default to the return air sensor because there's no way it can be set to use both at the same time.
Right. Right. So in effect, what you're doing is you're providing like a single set point, single blower speed, that kind of thing, right? So both indoor units are trying to maintain, let's say, 72 degrees. If one indoor unit detects that it needs a little bit more cooling or a little bit more heating, it's going to operate somewhat independently from the other system, right? Because it's using the return air sensors in that case to determine how fast it should run, right? Yeah. Anything else you'd like to add to that?
I guess you could probably still set it to wired controller only for sensing room temperature.
You could. I mean, I guess it would also depend on the application. If you're talking about 2 units being in the same room, yes, absolutely. If you're talking about 2 different floors, probably not.
Yeah, you'd be better off to leave them as the return air sensor. Yep.
Yeah,
and that's one thing I like about the GREE controls, and a lot of guys don't really quite understand is like, why do these things have so many different options? It's because not every job is the same. I mean, for example, I can talk about mine. I run mine in heating mode for my air handler. I run it at medium high in heating mode because my registers are on the ceiling at a 15-foot vault. So if I leave it in auto, I don't get enough throw off the registers to push that heat down toward the floor. So if I run it on medium high, then I do get enough throw to get it off the registers. And then what I do come summertime, I turn it back to auto because I want that. I don't want to throw that cold air reservoir off those registers. I want it to gradually sink through that living room and I get a nice, cool living room, kitchen, dining room area. So that's just one example of it. Depends on the job and what's going on, how the equipment's installed, registers in the floor, registers in the ceiling, returns low, returns high. All of that plays a role into how you set up that controller.
Right. I believe the follow-up is the default to the return air sensor where. So depending on the unit, on a wall mount unit, that is a space temperature sensor. It's located in the bottom right-hand portion of the cabinet, which can be relocated to the return airstream. This depends on the application. For ducted units, that is in the return airstream just below the coil, or just behind the coil, depending on which ducted unit you're talking about. The sets in the return airstream. I mean, there's a handful of different places that they're put them, but really the only one that would be different is the wall mount. But all the other ones would be in the return airstream. So, there may be some applications where we'd have to figure something else out. If you had like an incredibly long return that wasn't very insulated, going through an attic space or something, that could throw off the temperature a little bit.
especially in heating mode, because your fan defaults to off.
Yeah, like when it satisfies, it goes to off. Yeah, correct. So you might not be reading what you want to read, that kind of thing. But you know, one of the updates and one of the latest controllers that will be coming out is whether or not you want it to go to off in cooling or heat. As a matter of fact, if you want to continue that blower speed, if you want to continue that blower speed, even when it does cycle off, so that you can read an accurate temperature, let's say in a particular application, you can absolutely do that with the new controller that we've got coming out. Okay. Speaking of which, this kind of relates back to the zone system question that we had. I encourage you, as a person who purchased this equipment, to take a look at the price difference between a FLEXX system with a zone damper system and a MultiPRO system with an equivalent amount of indoor units. So if you're taking a zone damper system where it's two zones, like one for upstairs and one for downstairs, you might find that taking two of the horizontal ducted units with one outdoor unit is going to be, it could be pretty close to the price of a, let's say a FLEXX and a zone damper system. And in that case, what you're actually getting is true zoning, right? You're getting, fully inverter driven true zoning capability in that case, only providing what the heating and cooling that you need in the spaces that you're trying to do. And, just take a look at the pricing on it, so contact your supplier and find out what the price difference might be. And you may be surprised.
And I think, James, you're the one that came up with that terminology, and I liked it. It's zoning by refrigerant.
Yeah.
I don't think I couldn't take credit for that. But yeah, you're zoning by refrigerant rather than by air, right? I don't need a dump zone for my refrigerant. I'm not returning cold air back through a coil. I'm not trying to send liquid back to my compressor. I'm not trying to do any of those things.
And your compressor is running at the load requirement of whichever unit is running inside, whether it's one or both or three or four, however many indoor units you have.
Right. And the thing is about that true zoning capability is that requires nothing from you as the installer or as the contractor. You're not having to set up what percentage it's going to open at what rate, or a bypass damper, what percentage at what rate. That's all taken care of. Right. That's all done out of the box. You still set, static pressures and that kind of thing. But
you got a little more work in refrigerant piping if you're doing multiple zones and stuff like that. But as far as actual control setup, as far as zoning by refrigerant, there's no control setup you got to do other than if you're putting in wired controllers and stuff like that. You might set
I would rather run refrigerant pipe than run ductwork and zone dampers and bypass dampers and dump, all that.
Because where a lot of those zone dampers located? Up in the attic.
Right.
So when a damper goes out, you're going up in the attic.
You're in the attic hunting it because it's covered up with insulation.
Hoping you
don't. And you're up there ruining the R value of the insulation that's up there.
Right.
And crawling around on it, sweating on it,
Yep.
Yeah.
Now let's be realistic. If it was me, I'd be sending a rookie up there, because as big as I am, I ain't getting up there.
Okay. Well, I believe we're just going to wrap that up. Any questions that we didn't get to, we're going to, see if we can just reach out to you and answer those individual questions. Sometimes the questions can be a little bit more, a little too detailed for the audience or the podcast in this case, and or sometimes it's maybe a problem that we just have to handle on a separate note. But we do our best to answer all the questions that we have coming in on every episode. So that does it for Talking Comfort Live for this month. We'll see you next time, and until then, remember, at GREE, we're by your side.
By your side.
Hey, thanks for watching Talking Comfort Live with GREE HVAC. Make sure to keep a lookout for an invite to our next show, or subscribe to our GREE Comfort YouTube channel to make sure you get notified anytime we release new content.